protocols observed. I think I've been given 15 minutes, so I'll try to be as brief as possible. As Professor said, I want to talk on the issue of integration of digital technologies in planning, operation, and maintenance to enhance resilience and safety for the energy networks. So I had a small presentation here just to guide me on the way I'm going to present this talk. And I'm glad that the President has raised a lot of issues. And I think all those issues are in this presentation, and we will be seeing them. So very brief, I'll proceed with the presentation so that we can see how modern digital technologies are assisting, or we are planning to have them, so that we can have a resilient and a safe infrastructure. So I'll not go to the introduction so much because of the time. I'll also not go to the generation, that the energy infrastructure that you know. I think you're all versed with the energy infrastructure that we have. That is generation. We have transmission and distribution. I think maybe I would mention something a little bit here, probably just for information, is that transmission and distribution here is that transmission is being handled currently by KETRACO and KPLC. There are plans that transmission to be transferred to KETRACO, but it is still at some stage, so we are still handling it as KPLC. Then we have the distribution network, which is being handled entirely by KPLC, and currently we have licensed distribution licensees. We have the rural electrification. I've seen we have representation from rural electrification. KPLC is also involved in rural electrification through the last mile connectivity program, and of course the rest of the programs handled by REREC. We have petroleum, and most importantly, we have our regulator, who is IPRA, who plays a very critical role in regulating the energy sector and ensuring fair competition and compliance with standards. Then in this sector, I think we have some challenges which partly address what the President was talking about. One of them is aging infrastructure. The other one is intermittency. Basically, let's say due to the renewable energies that have come in. And of course, there is a very big need for investment in transmission and distribution. I'm sure Engineer Kipkemoyo Kibias will talk about the need that we need for investment in transmission, which is actually a challenge for us in this sector. However, we have opportunities. And one of the opportunities that we have is expansion of the renewable energies. And what we are talking about, the integration of modern digital technologies, should be a very big opportunity for the sector. What we are looking at, I wanted maybe to talk about a little more, is the issue of safety and resilience. And for sure, as the topic says, safety and resilience actually are very key for the sector, basically because they give us the reliability and the sustainability of the energy supply. When you look at safety, very key attributes here. One of them is protection of human life in the energy sector. First and foremost is prevention of accidents. We normally have explosion, fires, and electric shocks that can lead to injuries and fatalities. The regulator is well represented here. I'm not sure whether he's going to talk about the issue of electrocution. I also don't want to talk about it, but I'm sure it is in public domain, and it's a very pertinent discussion. And one of the things that mostly happens is that everybody in the house has become an engineer or an electrician, and yet therefore they know what they know, and they end up being electrocuted. And that's why we are getting so many public electrocutions. Something also that happens here, especially in the region that I work, is that because of burglary, people have devised a way of putting off burglars by electrocuting their metal frames, window frames. And for sure, when the burglar comes, there may be an injury or an electrocution. And for sure, that is safety and it is illegal. So when you see those guys who are doing that, energizing their metal frames so that they can deter burglars, it is illegal and it can cause injury and death. And of course, we are looking at occupational health to protect the health of the workers in the industry because of the hazardous environment. Again, environmental protection. We are dealing with things like oil, especially in electricity industry, and I'm sure, of course, in the pipeline industry, those are the key areas. So avoiding oils, leaks, and so on and so forth is also very key for the industry. And of course, it is a compliance issue. When NEMA comes and you've spilled oil, you're likely to be penalized. So we are looking at that in terms of safety issues. Integrity of our equipment. We need to do regular inspections to avoid equipment from failing, and also implement risk management strategies to minimize impacts of accidents. Of course, public trust is key. If you are free of accident, then the public will trust you. Now, here is the other issue that the president said. This is about resilience. How resilient how is the infrastructure ability to withstand disruptions? And here we are basically talking about natural disasters. I'm not sure we have had earthquakes in Kenya or even hurricanes. There was a hurricane in Mombasa, but I'm not sure how far it went. But even other issues like big winds, rains, as the president was saying, have actually disrupted power, as you have heard here. So that is an issue of resilience that we are looking at. Sorry, that slide moved fast. I think it had been recorded. So I want to agree with President, yes, our systems could not be resilient enough. That's why during the rains, during the winds, we have the system going down. The other thing I wanted to talk about resilience is I don't know, I missed that slide. We were talking about the resilience in terms of yes, I think I had recorded it so that it will move very fast. But I thought I would expound more on that issue. Yes, it is true. We have had interruptions. And a few other areas, maybe just normal technical failures. And with those technical failures, the question you're asking, do we have the ability to have redundancies such that if it's a technical failure, then how do we have redundancy so that we are not able to have that interruption that we are talking about? We've talked about adaptability to change and to change in demand and so on, or even infrastructural changes. And of course, economic stability, that is minimizing losses. So I wanted to move very fast because I've been given very few minutes. That's why I think the slide is moving very fast. Then finally, what we are looking at is the tools. What tools are we using in planning? And the tools we are using in planning, design, operations, and maintenance. So we have several tools that we are using, especially in planning. And one of the tools that we are using in planning is data analytics, GIS, and simulation tools. So data analytics probably is the issue of data collection. We use for demand forecasting, for load management, asset performance, and condition monitoring, and process optimization. And when we look at what are the advantages of data analytics, you realize that my slide is moving faster than I'm moving. Okay, we are already at GIS. You can check for me what's happening there as I look on the data analytics. So I will just proceed. I was saying we have data analytics, we have simulation tools, and we have GIS. So we are using data analytics for a number of things. You can go back to slide 26. We are using data analytics for demand forecasting, that we are able to find the future management, load management, asset performance, conditional monitoring, and process optimization, energy efficiency, cost reduction, dashboards and reports, very good, and real-time monitoring and performance benchmarking, and integration with other technologies, like the technologies of IoTs and sensors. Integration with the cloud computing. Then finally on this, we are having a number of challenges, data quality and cyber security. And of course, skills development is an issue here. The other tool is GIS. GIS also plays a very crucial role here. And for GIS, we are using it for site selection and planning, environmental impact assessment, asset mapping, maintenance planning, spatial analysis, demand forecast, disaster management, real-time monitoring, visualization, and scenario planning. This is what I'm saying we need to integrate with IoT, that is Internet of Things, which I'll talk about briefly. Advanced data analytics, and the challenges we're having with GIS and all over, I think data quality is an issue, and interoperability with other systems for better use to enhance resilience and safety. Then capacity is also an issue here, which is skills development. That's just a map of what we use GIS for mapping our tools. That's like our transmission network. When we go to simulation tools, again, here we are using them for analyzing, optimizing electrical power system. This can provide with advanced capabilities. Specifically, simulation tools for electrical are very good because they allow detailed modeling of power plants, transmission lines, transformer generators, and other components of the system. They can do what we call steady state analysis. That is analyzing the system, how it should be and how it will be after the fault. We can do optimization of load flow. This one is for good economic dispatch of energy. Once you do the simulation, you can be able to know which generation you're going to schedule, and it reduces cost. You can do visual reports, very fast tools and graphs for decision making, even before you implement your projects. And finally, this is very useful for grid expansion, because you can plan new infrastructure where you want to add a new generator, a new transmission line, and you're able to optimize your network. Again, here we also use it for operational studies, such as load flow analysis, voltage profile, short circuit analysis, and the rest. Integration of renewable energies. This is an issue that is becoming a challenge because of the intermittency. If you use these tools, then you can be able to place your renewable generation very well. Then we have emergency contingency planning, where you say, if I lose this line or this generator, what next? That is what the tool does. We call it contingency planning. Then applications, we can use it for regulatory compliance. You know, the regulator needs us to have some specific grid reliability indices